Right now, I'll demonstrate the draw that will be explained in the problem that my partner will be working on later on in the video. So, here's the object, and I'll be starting off with my height, so that way it's easier. So I'm 5'3", so that's going to be the height that we'll be using, and I'll just drop it.
So we just watched our friend drop an object. Let's break that down a bit. So this section, we're talking about the conservation of energy. And what that explains is that the initial energy will always equal its final energy. In our example with train, the object is at rest. And what that means is potential energy is at its greatest and kinetic energy will be at its lowest. So potential energy will be greater than kinetic energy. As the object falls, potential energy is decreasing while kinetic energy is increasing, all the way to the point where kinetic energy will be greater than potential energy. Yeah, for sure.
As explained earlier, Trang dropped the object at 5'3", and Dom stated that initial energy equals the final energy. Final velocity is what we're trying to look for, and since we don't want to use the kinematics equation, we use the conservation of energy to solve the problem. Since the height is not in SI units, we converted it to be at 1.6 meters using conversion factors. Now that we have the right units, we can use the equation to solve for final velocity. UGI and KI is the total initial energy, and UGF and KF is the total final energy. UGI is the initial potential energy of gravitation labeled as mgh1, and Ki is the initial kinetic energy labeled 0. Since it is at rest, the initial velocity is 0. Plugging in the kinetic energy 1/2 mv squared would give you 0. UGF is the final potential energy of gravitation labeled mgh2, and Kf is the final kinetic energy labeled 1/2 mvf squared. Since we are calculating velocity of a specific object, mass is negligible because we are focusing on one object in a given system, and it is proven by the elimination of mass in the equation. Since we have all that info, we could solve for Vf, which is the square root of 2 times the quantity gh1 minus gh2. Notice that h2 is 0 since we want to find the final velocity at the bottom. We plug in our numbers and solve for Vf, which is 5.6 meters per second.